Good morning, everybody. Mr. Rowan here, and we are back with Unit 4, Day 4. And what we are talking about today is our congruence theorems. So, what this means is the first one is side, side, side. So, if three sides of a triangle are congruent to three sides of another triangle, then those triangles are congruent to each other. So, that means if BC is congruent to TH, and I'd recommend that you follow along with colored pencils on your own. You don't have to use the same colors that I'm using right here, but it certainly helps if you can see the difference, because what we're doing is we're actually kind of rotating these triangles in our head. And one place where kids get tripped up is they say, all right, BC is at the bottom, TR is at the bottom, so those are the congruent sides. But that's not the case. You have to pay attention to the hash marks. So BC and HT have one hash mark, TR and AC have two hash marks, and then BA and HR have three hash marks. And then we know that the angles are congruent, but we don't really care about that right now since we're using side, side, side. Yeah, so let's draw this in. Let's go down. So to our congruent statement, you remember from last class, we figured out that all we have to do is match up the letters. So ABC should go with, all right, so A is between blue and purple, so R is between blue and purple. H is between green and blue, so then we match it up like that. Okay, so now we're going to look at a proof. This is our first proof, and when we do a proof, there's always an objective. There's a thing that we have to prove. So when we start, we're going to always figure out what triangles we're trying to get first. Yeah. So, hang on. So there's always something that's given first. So if we say that AD is congruent to BC, that's given by the diagram. The diagram shows us with the hash marks which sides are congruent. So next we do AB is congruent to DC. That's also given because we can just see it on the diagram. Next, we have to match up this third side, which is BD and DB. So BD and DB. Okay, so we say DB is congruent to itself. It's congruent to DB. And that is what we call the reflexive property. When something is congruent to itself, we call that reflexive. Imagine like reflection. When you're looking in a mirror, you're looking at yourself. So it's the same idea. That's where the word comes from. And then the last thing that we're proving is we are going to look at our proof statement. So your last statement should always be what the prove statement is, what the prompt is asking you to prove. So triangle ABG is congruent to triangle CDB. And that is from side, side, side. We've named three sides of each triangle that are congruent to the other side. So side, side, side. And that's all you have to put. There, you did your first proof. Wasn't that easy? It gets a little harder, but not that much harder. Okay, let's recall some terminology while we're sitting here. So an included angle when we have two sides is the angle that basically forms those sides. So A is the included angle between BA and AC. When we're talking about included side, you know that RS is included between those two angles. So we have angle R and angle S. Now, where this comes into play is when we do side angle side congruence. So what we need to know is that when you have two sides and the included angle, that's very key. So if LN is congruent to ST, and then we have angle N and angle T, you know, because those are marked, and then MN, which is marked a little bit awkward, and then, well, RT is marked a little bit awkwardly. But so we know MN with a line segment is congruent to TR. So we can tell from a congruent statement that triangle MLN is congruent to which one? Whoa, can't move that. Let's try again. Yeah, so this is M. So M, what's the corresponding angle to M? So M is between a blue and a black line. So the one between a blue and a black line would be R. And next, S and L are both between the green and black. So that leaves N and T as the last set of corresponding angles. Okay, we're going to try another proof because we just cannot get enough. All right, so this time we're trying to prove that Hij is congruent to Kji. We're going to start off with the fact that Hi is congruent to Jk. And again, that's given. We always start with our givens, what it tells us in the prompt or on the diagram. Next is you'll notice there are these little arrows too. Remember what those mean? Those mean that the line segments are also going to be parallel to each other. So Hi is parallel to Jk, and that is also given. Okay, let's see if we can think of something else. All right, let's take a look at our angles. So we have angle I and angle J. And what's those relationships if they are parallel? Well, those should actually be alternate interior angles. So when we name our angle, we're going to make sure that we use 3 points because there's multiple different angle I's that we could use. So we're going to do Hij, just tracing along the angle like this, and then Ijk or Kji. Either way works because they are alternate interior angles, and alternate interior angles are always congruent, and that's what you'll write for that. Now last, well, not quite last, but fourth, we have a relationship that we saw in the last proof, which is we have whenever the triangles that we're proving congruent, whenever they share a side, we can use the reflexive property to say that, all right, this line segment is congruent to itself. So I see Ji is congruent to Ji, and we're going to use the reflexive property here. And then last, we know what our statement should be because it tells us what we're trying to prove. Remember, our proof statement is always the last statement. So the first reason and the last statement should always be super easy because the first reason is always given and the last statement is always the prove statement. And how did we figure that out? Well, It's the theorem that we just learned. Side, angle, side. Shocker. Okay. So we are going to take a look at an example. So we're looking at KLM and which one. Okay, so we are going to try an example now. So we look at KLM and NMP. So which one goes with K? Well, it's between the 1 hash mark and the 3. So that would be N. And then L is between the 1 hash mark and the 2. So M would go there. And then P would be between P would correspond with M in that first triangle because that's between 2 and 3. So then we're going to ask ourselves, is it side, 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 or side, angle, side? And that should be relatively simple because we do not know the angle. So, what do you think it is? Side, 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 or side, angle, side? Okay, and that's all I have for you. So enjoy the rest of your weekend or week whenever you're watching this. Bye.